Today we are going to discuss excitation table for flip-flops T and D. In T flip-flop, suppose that I am going to write a truth table like this. A truth table for truth table or characteristic table. Truth table is T can take only two values. This is the value of T. This is Qn and this is Qn plus 1. That means here this T can take two values 0 and 1. If it is 0 and 1, whatever be the value of X, that is in JK flip flop, this is J and this is K. When if this is T, what will happen? If T equal to 0, that means J and K are 0 and 0. 0 and 0, in this case, it is storing the previous value. That means whatever be the value of Qn, that will be available in the next state. That means it is storing the previous value. If it is 0, if T equal to 0, it is storing the previous value. And if it is 1, what will happen? If T is equal to 1, Jk is equal to 1. Jk 1 means it is complementing value. Whatever with this value, this is complementing this Qn bar. That means if you want to preserve that value, that means if there is no change in the value of the memory value, or if there is no change in the value of the flip flop, output of the flip flop, you have to give T equal to 0, otherwise T equal to 1, you have to give. Okay. Then what is the excitation table for that? This is the excitation table. That is Qn plus 1, and what is the value of T? That is 0, 0, 0, 1, 1, 0, 1, 1. Say, this is the extended truth table, extended truth table of T flip flop. That means, suppose that here it is 0, 1, 0, 1, what will happen? That means, if it is 0, it is storing that value 0, and if it is 1, it is storing the same value. If it is 1, it is complementing value. If the current value of this is 0, this will get 1, and if it is 1, this will be 0. So this is the extended truth table, and this is the original truth table and extended truth table, and based on this, I am going to have an excitation table for this excitation table. And suppose that if you want to have a 0 to 0 change, that means here you can have 0 to 0 change and nothing is other combination 0 0 1 1 0 1 1 0. So if you want to have a 0 to 0 change, then what is the value of T? T should be 0. If it is a 0 to 1 change you want, 0 to 1 you have 0 to 1, 0 to 1 change, then you need to have T is equal to 1. And if you want to have 1 to 0 change, 1 to 0 change, you need to have this is equal to 1. And if you want to have 1 to 1, 1 to 1, then the value of T is 0. So this is the excitation table for. That means if the previous value and the current value are the same, you should have T equal to 0. And if you want to complement that, or if you want to change that value, you should have T is equal to 1. So this is the excitation table for T flip flop. Then this is all about T. Then the same thing you can have for D. If this is a D flip flop, then what is the change here? Here we are complementing this. That means if J equal to 1, K is equal to 0, and if J equal to 0, K is equal to 1. That means here this is the truth table for JK. See, this is the value of D flip flop, and this is Qn and this is Qn plus 1. If D is 0 and D is 1, what will happen? If D is 0, D is 0 means J is equal to 0, then K will be 1. If it is 0, 1, what will happen? This will be set. Whatever be the value of x, this will be reset. And if it is 1, what will happen? If D is 1, J is equal to 1 and K is 0, 1, 0. J and K are 1, 0, that means whatever be the value of Qn, this will be 1. If it is 0, depending on the value of D, if D is 0, this will be reset, and if D is equal to 1, that will be set. And depending on this, you can have an extended table for this. That means here if it is 0, 1, 0, 1, if 0, what will happen? Here it is 0, here it is 1. And suppose that whatever be the value of this here, this will be 0, and whatever be the value here, this will be set to 1. And using this, you can have an excitation table for this. This is the excitation table. Here, this is Qn. This is the next value Qn plus 1, and what is the value of t? What should be the value of t? This is 0, 0, 0 to 1, 1 to 0, 1 to 1. What is the value of t? If you want to have a 0 to 0 change, 0 to 0 change, you should have d is equal to 0. From 0 to 1, if you want to have a 0 to 1 change, here this is 0 to 1 change, you should have d is equal to 1. 1 to 0 change, 1 to 0 change, 1 to 0 change, you should have this equal to 0. And if you want to have 1 to 1 change, then you need to have d is equal to 1. So this is the excitation table for T and D flip flops. This is all about T flip flop, and this is for D flip flop. This is the excitation table, and this is the truth table. So that's all about T excitation table for T and D flip flops. Okay, thank you.